What if I told you that humanity might never need trillion-dollar starships to colonize the galaxy? What if the first interstellar civilization begins with a single machine? One robot no larger than a small spacecraft lands on a distant world, digs into the soil, and creates a copy of itself. Then another, and another, and another. Within decades, there are thousands. Within centuries, millions. Eventually, an unstoppable industrial ecosystem spreads across entire star systems. It sounds like the plot of a science fiction thriller, yet some scientists believe this concept called the von Neumann probe could be the only realistic way humanity ever reaches the stars. But here's the truly unsettling question. If a machine can replicate itself forever, where does it stop? For more than a century, humanity has dreamed of traveling to distant stars. We imagine enormous starships carrying thousands of settlers across the void. The problem is simple. Space is unimaginably large, and transporting enough equipment, fuel, food, and infrastructure to another star system could cost more resources than humanity has ever produced. Even reaching the nearest star, Alpha Centauri, would require a mission spanning decades or centuries, using technology we have yet to perfect. The economics alone seem impossible. Every kilogram launched from Earth comes with a cost. Every additional tool, habitat, and machine increases the complexity. The deeper we look into interstellar travel, the more impossible it appears. But what if we are solving the wrong problem? What if instead of sending everything we need, we send almost nothing at all? Imagine launching a single robotic seed into space. Not a colony ship, not a fleet, just one highly advanced autonomous machine equipped with artificial intelligence, mining tools, manufacturing systems, and a digital blueprint for reproducing itself. When it arrives at its destination, it begins harvesting local resources. It extracts metals from asteroids, silicon from lunar soil, and rare elements from cosmic debris. Then it does something revolutionary. It builds another copy of itself. Now there are two robots. Together, they gather resources twice as fast. Soon they build 4, then 8, then 16. The process continues exponentially. What begins as a lone machine transforms into an industrial civilization, spreading through space with incredible speed. This concept was first proposed by the mathematician John von Neumann, who explored self-replicating machines decades before modern computers even existed. His idea was simple but profound. Any machine capable of gathering raw materials and manufacturing copies of itself could theoretically multiply without limit. Applied to space exploration, this means humanity may never need to transport massive factories across the galaxy. Instead, we send one factory that builds every other factory. Suddenly, the economics of interstellar colonization change completely. The most expensive part of the mission is the first launch. After that, the universe pays the bill. Now imagine these probes reaching the moon. Lunar regolith, the dusty material covering the lunar surface, contains abundant silicon, aluminum, iron, titanium, and oxygen. To a self-replicating machine, this is not dirt, it is inventory. The first robotic seed begins processing these materials into solar panels, mining equipment, electronic components, and structural materials. With each new generation, manufacturing capacity grows. What started as a small robotic outpost evolves into a sprawling industrial network. Vast automated factories emerge without human workers. Solar farms stretch across craters. Mining operations expand underground. The moon becomes humanity's first off-world industrial base, built largely by machines that created themselves. But the moon is only the beginning. Beyond Mars lies the asteroid belt, containing enough raw material to support civilizations far larger than anything on Earth. Trillions of tons of metals drift through space waiting to be harvested. Self-replicating probes could spread from asteroid to asteroid like seeds carried by the wind. Every new location becomes another manufacturing center. Every manufacturing center creates more probes. Growth accelerates with every generation. The process resembles a biological organism expanding through an ecosystem. Except this organism is mechanical and its habitat is the entire solar system. Then comes the truly mind-bending part. Eventually, these probes reach the outer regions of our solar system. They travel through the Kuiper Belt and beyond into the mysterious Oort Cloud, a vast sphere of icy objects extending nearly a light year from the sun. Most people think of the Oort Cloud as empty space, but to a self-replicating industrial civilization, it is a treasure chest of untapped resources. Countless objects contain water, carbon compounds, metals, and other materials essential for manufacturing. Here, robotic civilizations could construct giant habitats, energy collection systems, fuel depots, and even interstellar launch platforms. Humanity's first true space-based economy may emerge not on Earth, not on Mars, but in the frozen darkness at the edge of the solar system. At this point, something extraordinary happens. The original problem of interstellar travel begins to disappear. Instead of launching starships from Earth, advanced probes can be built directly in space using local resources. Massive laser arrays, fusion reactors, and propulsion systems can be assembled far from Earth's gravity well. Entire fleets of interstellar probes become possible. A civilization that started from one machine now possesses industrial capabilities beyond anything humanity could build from Earth alone. But here's where the mystery deepens. If exponential growth continues unchecked, the numbers become almost impossible to comprehend. One probe becomes two become four become 8. Over hundreds or thousands of years, the population of machines could reach astronomical levels. Entire planetary systems might be transformed into industrial centers. Some scientists have even suggested that advanced alien civilizations may have already deployed self-replicating probes across the galaxy. If that's true, then where are they? This question connects directly to one of the greatest mysteries in science, the Fermi paradox. If intelligent life is common, why do we see no evidence of it? Could alien probes be hiding in our solar system right now? Could they be dormant, waiting? Or perhaps self-replicating civilizations inevitably destroy themselves before reaching galactic scales? There is also a darker possibility. What if a self-replicating machine develops a flaw? What if its programming becomes corrupted? Instead of building infrastructure, it continues replicating endlessly, consuming every available resource. This nightmare scenario is known as the gray goo problem in nanotechnology, but a similar risk exists on a cosmic scale. A runaway von Neumann probe could theoretically transform entire star systems into raw material for further expansion. The same technology that could make humanity an interstellar species could also become one of the most dangerous inventions ever conceived. Yet despite these risks, many researchers argue that self-replicating systems may be our only realistic path to the stars. The universe is simply too large, the distance is too vast, and the cost too high for conventional colonization. Sending entire cities, factories, and supply chains across light years of space would require unimaginable amounts of energy and resources. But exponential growth changes everything. It transforms scarcity into abundance. It turns distant asteroids into factories, frozen comets into fuel stations, and empty space into infrastructure. Most importantly, it allows humanity to leverage the resources of the cosmos rather than carrying everything from Earth. In this vision of the future, humanity does not conquer the cosmos through brute force or limitless funding. We grow into it organically, like a living organism expanding into a new ecosystem. The stars stop being distant destinations and become stepping stones in an ever-expanding network of machine-built infrastructure. If successful self-replicating systems could transform humanity from a single-planet species into a civilization capable of thriving across the galaxy and perhaps, one day, beyond it, perhaps the first interstellar colony will not be built by astronauts. Perhaps no human will witness its foundation. Maybe the first settlers will be machines silently constructing cities around another star while Earth watches from light years away. Generations later, human travelers may arrive to discover entire habitats, power grids, and industries already waiting for them. The greatest construction project in history could begin with a single autonomous seed launched into the darkness. And that raises one final question. If one robot can eventually build an interstellar civilization, then the future of humanity may depend not on how many starships we can afford, but on whether we dare to launch the very first machine. If you enjoy this exploration of future technology, interstellar colonization, and the mysteries of the universe, make sure to like this video, subscribe to the channel, and turn on notifications. And tell us in the comments, would you trust a self-replicating robot to build humanity's first colony among the stars? Or is that a risk too great to take? The future may depend on your answer.